Now here I am going to analyze the questions from the quiz. So the first thing you have to consider in all the questions, whatever is the given parameter, you have to write first. How many things are given in your question? First you write all the given things. Like this, something, if this one is given to you and the second parameter is given, or the third parameter is given, or the fourth parameter is given. Now after getting all the given information, you write what you have to find, what the question is saying to find. Now on the basis of this information and what you have to find on the basis of this information, you think, okay, you think what is the relation between the given data and the parameter you have to find. So here you have to find the relation. Okay, relation means you have to find the formula, you have to think the formula which relates between the information which is given and what the parameter you have to find. So after relating the given information and what parameter you have to find, you write the formula and then you start. So this is the correct step to find the solution of any equation. Question number 1, the part 1. A solenoid has 202 turns of wire. So this 202 is the value of the capital N, and the length of the solenoid is 92.6 centimeter. So this 92.6 centimeter is the value of the L. This solenoid produces a magnetic field of 2.34 Gauss at its center. What is the current flowing through the solenoid? So in this question you have to find the value of the current flowing through the solenoid. Now what are the given in this question? The value of the capital N is 202 turns and the value of the L is 92.6 centimeter. So here the length you cannot take in centimeter, it should be in meter. So this value 92.6 multiplied by 10 to the power minus 2, so this is meter. So the value of the L is 92.6 multiplied by 10 to the power minus 2 meter. This should be in meter. Now the value of the B is given. This is 2.34 Gauss. So here the unit of the magnetic field is given in the Gauss. So you cannot take this Gauss. So this Gauss should be changed to Tesla. So the relation between the Gauss and the Tesla is that 1 Tesla is equal to 10 to the power 4 Gauss. So here you are changing this Gauss to Tesla. So what you have to do, this value, this is 2.34 multiplied by 10 to the power minus 4, and this will be converted to the Tesla. So when you are changing from Gauss to Tesla, you have to multiply by 10 to the power minus 4 from Gauss to Tesla. Now the formula for this problem is, that is what the formula we have to use for this problem. The formula for the magnetic field of the solenoid, this is B equal to, this is mu naught N I divided by, this is L. So in this question you have to find the value of the I. So this you have to find, this I you have to find. So what to do, you cross multiply like this, it will go this side. okay, and here everything it will come this side, and then after the cross multiplication this I it will come, this is B L over mu naught, and this is N. So this formula you have to use to find the value of the I. So now here we can put the values of the parameter here. So this I equal to, the value of the B is 2.34 into 10 to the power minus 4, and the value of the L is, this is 92.6, and this is multiplied by 10 to the power minus 2, and it is divided by this mu naught. So the value of this mu naught, this mu naught is constant, so the value of this mu naught will be given to you. The value of the mu naught is, this is 4 pi into 10 to the power minus 7, and this is multiplied by the number of turns and total number of turns. So the total number of turns are 202. And when you will solve this, whenever you are solving in your calculator, so always use the bracket. This should be in the bracket. So from here to here it should be in the bracket, and after the calculation the value of the I is coming, this is 0.853 ampere. So this is the answer for the current. Now in the part 2, in the given diagram of solenoid, this is a solenoid diagram, mention magnetic pole of end A and end B of the solenoid. So this, the meaning of this magnetic pole means it is a north pole or it is a south pole. So here this solenoid is like a magnet. This solenoid is like this. It is like a bar magnet. So if I say this is a bar magnet, north pole of the bar magnet and the south pole of the bar magnet, so the magnetic field goes like this. Okay, from the direction of this, it starts from the north pole and it moves from north pole to the south pole, and it is like this, and it is started from here and moving in the direction of the south. So in the south, okay, here like this, okay, they are going like this way. So here they are going out. So this, and here they are coming in. So this magnetic field lines are going inside. So inside the magnet, inside the bar magnet, and from here, from the north pole, this field lines are going outside. So this field lines are going outside from the bar magnet. So you have to use this concept to give, like, this end is north pole or the south pole, or this end is the north pole or the south pole, according to the concept of the direction of the magnetic field in the bar magnet. This is a bar magnet. So here you have to take care, like from the north pole the magnetic field goes out, and from the south pole the field goes in. So this is inside. So this, here we have to check, like particularly in this diagram, if you see here, actually here there are two methods, okay, but in this diagram, if you see these lines, okay, these lines are the magnetic field lines. So these lines are the magnetic field lines. Okay, now if you see here, these field lines are going out. So this arrow is telling here, this arrow is telling these fields are going out from this solenoid. So this is going out means like this. So they are going outside. Outside means this is the north pole. So here this end is the north pole of the solenoid, and if you see here at the other end, the end B, if you see in this portion here, how the arrow is looking, so this is a magnetic field lines and they are going inside. they are going inside the solenoid. So inside, the meaning of inside means this is south pole. So this end of this solenoid is the south pole. So this is the south pole, and here this is the north pole of the solenoid. But particularly in this question, there are two methods that you can give the answer for the for this solenoid, which end is a north pole and which end is a south pole. So the one is, if these magnetic field lines are given. So these lines are the magnetic field lines. So on the basis of the direction of these magnetic field lines, you can give the answer. But sometimes these magnetic field lines are not given, only the direction of the current given. So here, if I give the answer on the basis of the direction of the current which is flowing in this coil, in the last coil here at this end, so you have to use the right hand rule 2. So this right hand rule 2 you have to use to give the answer which pole is the which end is the north pole and which end is the south pole, by using this right hand rule 2. So in this right hand rule 2, the thumb is the thumb here. The right hand rule 2 is like this. You have to align your fingers. You have to fold your fingers like this. So these fingers are the direction of the current and where this thumb will go. So this is a thumb. So this thumb is the direction of the B, like this. So you have to put your hand in this area here. Okay, in this you have to put your hand here in this area. So first you have to check how this current is moving here. So see, this current is coming from here. This current is coming from this side, like this. From here it is coming like this way. So the current is, see here, the current, how the current is going. It is going from here, then moving like this, then moving like this, then moving like this, then moving like this. So here you have to identify what is the direction of the current which is flowing in the coil. Okay, so like this way. Okay, like here the current is here, here. So it is moving like this. It is moving like this way. So here if I see in the last loop, the current is going like this way. From here to here the current is coming like this. So here you have to use the hand. So this arrow is the direction of the current, and in the hand rule 2, this is the direction of the fingers. Okay, this fingers. So you have to align your hand this side. The fingers should be in the direction of this arrow. So if you are keeping your hand here, your thumb will go in this direction. So this is the direction of the thumb, and this thumb is the direction of the magnetic field B. So the thumb is coming this side. So the thumb is going out, means the magnetic field is going outside. So the field outside means this is the north pole. So in the same way you can use the right hand rule 2 at this side. So the same answer you will get. The thumb direction will come this side.